All right, so chapter 11 is about simulating events. And there's a list of steps we'll get into about what you need to do to simulate events. We're going to simulate events using random numbers. All right, so we're going to assign numbers to scenarios, and we'll simulate the numbers to see what happens. Okay, so to do that, we just need to talk about randomness for a second. Okay, a random number is only truly random if you can't predict what happens next. If you need to know what truly random is, it just means you can't predict what's going to happen next. So, for example, if you have a fair die and you roll the die, you shouldn't be able to predict what happens next. You should not. If you have a fair spinner and you just flick it the same amount each time, right, the same force, whatever, you shouldn't be able to predict what happens the next time, right? You just spin and stop. Okay? So something that's truly random means that you can't predict the next outcome. Now, if you're talking about a deck of cards, all right, and you draw a card and you don't replace it, the more you draw the card, the less random it's becoming because you can start to predict what's going to happen next. Does that make sense? Okay? So, just truly random means you can't predict the next outcome. So we're going to do a little experiment. I am going to put this grayed out part down in a second. There are 4 numbers listed. All right, you're going to pick one of the numbers in your mind. Okay, just pick a number out of the 4. And just pick it in your mind. Okay? Pick a number in your head. Yeah. All right, did everyone pick a number? Okay. This won't be as exact, but there's only 10 of you in this class. But in general, if you picked 3, 75% of people picked the number 3.
I picked 3.
I picked 3 too. I picked 3.
If you pick 2 or 4, about 20% of people pick 2 or 4. And then about 5% of people pick number 1. Okay, so I had like 2 people in first period pick number 1. And there's 26 people in that class. There you go. Well, here's the point I'm trying to make here. We can't just decide, since we're going to be using random numbers to simulate things, we ourselves are not going to be the ones that get to pick the random numbers. Like, I'm not going to say, okay, write down like 8 random numbers using number 1 through 5, because human beings psychologically will go to one number more often than another. Right? So if I said to write 25 numbers, like 25 numbers 1 through, like you're doing 1 through 5 each time. So you have 25 lines of paper and you write a 1 through a 5 each time. One of you guys is either going to start using a pattern, or if I said to make it random, you're going to start repeating the same number more than another one. Okay, so it's not truly random, and that's a psychological thing. Okay, so we are not going to be the ones picking the random numbers. All right, we're going to be using random number tables and our random number generator in our calculator. But that brings me to another point. Okay. Our random number generator in our calculator is not truly random. It's pseudo-random. Okay, and so are random number tables, because your random number generator in your calculator is based on a computer program. All right, so in your TI, it's programmed a extensive list of numbers. Okay, and it goes through, and every time you select a random number, right, it selects out of that list, and it keeps going through the list until it gets to the end of that list. And then it starts the list over again. Now, to you, the consumer, you would have no idea when that happens. All right? You're just picking random numbers with the generator each time. Okay? But technically, if you actually started charting it, okay, eventually it would be a long time. It's an extensive list. Like, we're not talking the list only has 7 numbers in it. Okay? Like, it has a long list of numbers. So eventually, it would start repeating itself. Okay? You won't know when that happens, though. Since we don't know when that happens, it's going to be so indistinguishable from actually random values that we still use it. Okay? Random number tables are just tables that are lists of numbers. Okay? Well, someone had to, like, generate that list of numbers, and if you get to the end of the list, you have to start over. Right? So, again, not truly random, but pseudo-random. Okay? Does that make sense? We're going to use those anyway, though, because it's just not going to make a difference. Okay, it won't matter as much. Generally, we're not going to go through the whole list anyway. We're not going to have that much stuff going on. Okay? If you want to look at the random number table in your book, it's like the last section of your book. It's Appendix G, so it's like really like the last section. My page number is different than yours, though, because mine has more stuff in it, so I don't know what page it's on. But it's Appendix G, and it's the first page, and it's just a list of numbers in groups of 5. Okay? Now, they're grouped in 5 not because they want you to look at them in groups of 5. You can look at them one at a time. They're in groups of 5 because if you're trying to use the table and you're trying to go across a row, you can easily lose your place. So they put them in groups of 5 so it's harder for you to lose your place. Okay? So there is a random number table in your book. So that means if you go home and you're trying to do an assignment and you need a random number and you don't have your calculator, you can just look in the back of your book and that'll suffice. Okay? We're probably going to use our calculator more often than not because it's just more efficient. But we will look at how to use the tables because when we do simulations, everyone's simulations are going to be a little bit different because everyone's calculators are going to be a little bit different. Okay? You're not going to get the same numbers in everyone's calculators. It's just not going to work. Okay? So because of that, everyone's going to have similar setups, but not the same result. And so if you use a number table, which is what they're going to do in the AP exam, you're forced to at least have a list of numbers so everyone has at least a similar result as well. All right? A free response grader can follow your work with a random number table because they have the numbers in front of them. They can't follow your work if you do it with a computer generated on your calculator or because they don't know what you did. Okay? So we'll practice both ways. Today we're just going to focus on the calculator, just as for ease and for time. Okay? So here is our scenario, all right, that we're going to simulate. It says, suppose a cereal manufacturer puts pictures of famous athletes on cards in boxes of cereal in the hope of boosting sales. The manufacturer announces that 20% of the boxes contain a picture of Tiger Woods, 30% a picture of David Beckham, and the rest a picture of Serena Williams. You want all 3 pictures. How many boxes of cereal do you expect to have to buy in order to get the complete set? So let's just say we were going to do this in real life. All right, this is a perfect scenario where you can't actually do this in real life. It wouldn't work out very well for you. But let's say that you were at the grocery store, whatever grocery store you choose to go to. All right, we'll say that these cards are all in Wheaties boxes. That seems legitimate, like, right, sports cards. So they're all in Wheaties boxes, and let's say that the manager has given you full reign to open the boxes without paying for them, which is also not a legitimate situation. But if you were doing that, all right, what would you do to get a complete set? You would just pick 10 boxes and open all of them and hope that you have a complete set. If you were going through the process of trying to get a complete set, you would open one box and see what card you had, and you open another box and see what card you had, and you keep opening boxes until you had a full set. Right? We're not trading. We're not buying off eBay either. We're just taking them out of cereal boxes. Okay, so you have to understand the process in order to set up the simulation. Okay? So the process is you're going to sit there and you're going to open one box at a time and look at the card until you have all 3 cards. Right? So when we simulate that with random values, that's what we're going to be doing with the random values. All right? Now, just so everyone is on the same page here with the percentages, if 20% have Tiger Woods and 30% have David Beckham, what percent are Serena Williams? 50, because we're going to need to know that in a second. Okay? Now, there's a certain sequence of steps you must go through and write about. In the first example, we're just going to split them all up, and then the next example, we're going to put them in paragraph form. All right, there's certain things you need to have to set up your simulation, and then you're actually going to simulate and go through doing it all. Okay? Now, a simulation has multiple trials because, so there's, 9 of you here today? I could send all 9 of you guys to different grocery stores in the area. I could send you guys to Tennessee. I could send you guys to Benton, whatever. I could send you to grocery stores across western Kentucky. All right? And I could ask all of you to do the same thing. All right? Buy a box of cereal, see what card's in it. Buy another box, see what card's in it, and keep buying boxes so you have a complete set. Right? And all of you guys will come back with a different number of boxes of cereal you had to buy. Generally. Right? You're not all going to come back and say, I had to buy 3 boxes. Okay? That's not going to happen. All right? So since we're trying to figure out how many boxes of cereal you expect to have to buy, all right? Then we're going to do the simulation multiple times and then take an average at the end, all right? We're going to see, okay, this trial this happened, and this trial this happened, and this trial this happened, and we're going to go through and average them so we can say, okay, it seems like it takes about 7 boxes, or it seems like it takes about 4 boxes, or whatever. Okay, does that make sense? So you can't just do one run of this. You have to do multiple. That's what we're going to use for calculator. It's just time efficient. All right. So here we go. It just the setup just tells you about what a trial is. So here are things we're going to do. The first thing is to identify the components to be repeated. A component is just a building block or what your random numbers are going to represent. So we're going to assign numbers, in this case, to, you think of it 2 ways, to the people on the cards or to the cereal boxes, right? One number is going to be a card in a cereal box. Does that make sense? So our component is going to be card or one cereal box, since one card comes in one cereal box. That is our building block. And we talked about if we were in the store, we'd have to keep buying boxes until we got a complete set, right? So one card / one box of cereal is a component, our building block of what's happening. 2 says you need to explain how you will model the component's outcome. This is where we assign random numbers. This is the confusing part, not because it's actually confusing, just because every single scenario is different. So every single setup is different, all right? It's not always just like this problem. So I'm going to do this problem that's based off percentages, and then the next example I'm going to do is not based off percentages. So it's just going to be different, okay? This problem is based off of percentages, though. We have 20% are Tiger Woods cards, 30% are David Beckham cards, and 50% are Serena Williams cards. Right, that was in the setup for us, okay? I need to assign random digits. So, you have a few options. This is out of 100%, right? So, you could use 100 digits to represent this. 20 of them would be Tiger Woods, and 30 of them would be David Beckham, and 50 of them would be Serena Williams. Right? We want the random digits, the probability of getting those random digits, to match our probabilities of this happening. Okay? Does that make sense? So we don't want to assign like a number 1 to Tiger Woods, a number 2 to David Beckham, and a number 3 to Serena Williams, because those would all be equally likely. All right? We want to have a scenario where our percentages match the number of digits that we're using, or the percentages match the probability of those digits occurring. All right? So you could just do it out of 100. Since all of these percentages are 10%, though, we could also do 10 digits. Right? We could do 2 digits for Tiger Woods, and 3 digits for David Beckham, and 5 digits for Serena Williams. Does that make sense? Neither way is the one way you should do it. You can do it either way. It doesn't matter. Okay? Here are some things you should know, because things our book's going to do and things about why I would say to do this. Because we're going to practice with random number tables. Okay? If you're looking at random number tables, you have to look at the same number of digits each time. So, if you're going to do 10 digits, I would not advise that you use number 1 through 10. All right, this is why. If you use 1 through 10, 10 is a 2-digit number. So if I was using a random number table, I would need to go through and look at 2 digits at a time, which means 1 would be represented by 0, 1, and 2 would be 0, 2. It's not the end of the world. I just necessarily wouldn't advise to do that when you're doing a table, because you have to look at 2 digits all of a sudden. All right? I could instead do 0 through 9, and then I have to look at 1-digit numbers, where I can look at 0, I can look at the first number, and the next number, and the next number, and the next number. It's not that one is better than the other. I'm just trying to save you from having to look at 2 digits each time. If you're basing this off 100%, so you're going to do 20 numbers and then 30 and 50, I would definitely advise that you don't do 1 to 100. Because then you have to look at 3-digit numbers, right? Because you have to look at the same number of digits each time. So 1 becomes 0, 0, 1 instead of just 1. Okay? You can't just like choose to look at 3 digits one time and 2 digits this time and 1 digit that time. You have to look at the same number of digits each time to make it fair. So because of that, I would again advise to do 0, 0 to 99, because then at least you're looking at double digits instead of triple digits. Okay? If you're using your calculator, it doesn't matter. Because your calculator will pick whatever it wants to pick. It doesn't matter how many digits it is. You can tell the calculator to pick a number between 1 and 10, and it'll do it. But if you're using a table, you need to make sure that you kind of think through that. So just for argument's sake, and just because that's what I'm going to do, I'm going to use numbers 0 through 9. Okay? Again, if you wanted to do 1 through 10, you're going to use your calculator. More power to you. I'm going to use 0 through 9. So if I use 0 through 9, I need 2 numbers to represent Tiger Woods. So I'm just going to say 0 and 1 are Tiger Woods. Right? 2 numbers out of 10, that's 20%. So the probability matches what's happened. Then 2 through 4 would be David Beckham. That's 3 numbers. 30% matches up. And then 5 through 9 for Serena Williams. 50%. Is everyone on the same page about how I'm assigning numbers? Maybe. All right. Then it says you need to explain how you combine the components to model a trial. We already talked about what we do in the store, so we're going to do the same thing with a calculator, all right? I will generate a random digit, or random number, until a complete set is achieved. So that means maybe I'm going to have to generate 3 numbers and I'm done. Maybe I have to generate 10 numbers until I'm done. I don't know. It's random. Can't tell you what it's going to be. Okay, so you're just going to tell them what you're going to do for each trial. And then to stay with the response variable is, that's just what you're trying to achieve. You're trying to figure out the average number of boxes you must open. Okay? Yeah? So we're going to run this together. You need somewhere that you can keep track of what's happening, because you can't keep track of it all in your head. All right? So trial number, your result. And in this case, we're looking for the total boxes it took for that trial. Now, generally, as a rule in this class, regardless of what it says on the assignment or on the problem, you should be running 10 trials. Today in class, I'm probably going to run 3 for time's sake, all right? But you should be running 10 trials. So some of the questions say just run some trials, so that means 10. Some say run 20, and I'll let you do 10 because 20 is extensive. Okay? So run 10. So first try, you should never do this. You shouldn't go back for putting a table and a calculator, but I'll show you both. Okay? So the first trial, I'm going to use the random number table. They give us this list of numbers right here. So like this is what the AP test to do. They give you a list of numbers to use. Okay? Now we already said what our numbers were, but just as a reminder. So trial 1. So we're looking at 1-digit numbers. So we started the first number in the list. All right? 8 represents Serena Williams. Right? 9 represents Serena Williams. 0 represents Tiger Woods. 6 is Serena Williams. 4 is David Beckham. So now I have 1 of each card and I can stop. So it took me 5 boxes to get all 3. Okay? And if you do the next one, you would do, I'm just going to write it above here. So 7 is Serena Williams. 3 is David Beckham. And 0 is Tiger Woods. So that took me 3. Okay? Now, that's if you're using a table, totally acceptable, not a problem. If you're going to use a table in your book, don't start at line 1 each time. Like, pick a random line to start at, okay? You can also use your calculator. So they don't provide you with a list of numbers, so you have to flip back and forth and stuff, because you can't really write in your book. You can use your calculator. You hit math. I don't know where it is in the Inspire. It's probably the same place, though. Similar thing. Math. Probability, and then you want to choose number 5 where it says random integer. If you have a color, it's going to give you a menu. If you don't, you just see what I have on the screen. Okay? You just type in what numbers you want to choose from. I want to choose a number between 0 and 9. So I type 0, comma, 9. It's right above the 7. 7. It's the button number above 7. All right, so 0, 9, I hit it. I get a 3. Yeah, everyone's probably getting something different. It's fine. And so 3 would be a David Beckham card. And then you don't have to type it in again. You should enter it as again.
Oh my gosh. Freaky. Holy moly. There's time. Oh my god. 9221. That's weird.
And so you just keep going until you get what you're supposed to get. Like, this is going to apparently take me forever. All right, so that one took me 1, 2, 3, 4, 5, 6, 7 boxes. Okay? Yes? If you have a color, it asks for a N, so number of numbers you want. We'll worry about that with the 84s tomorrow.
Just like messing around with it.
Yeah.
Apparently there's a thing called random speed. So
Yes.
random speed 5, and my calculator says 10.
Yes. I can seed all the calculators. Because it's a computer program, I can seed all the calculators to start at the same place in the computer program. That's what you're doing. You just don't know that you're doing that.
Okay. Did I do anything wrong? Or just
No, it's just going to start in a random place at the 5th place in the computer program. All right, so does that make sense?
cool.
Now, normally, again, I would do 10 trials, but I'm not doing 10 trials today. So then you have to state a conclusion. All right, you have to conclude what's happening. So I would go through, I'm looking for the average number of boxes it would take me to get 3 cards, right, the set. So I would go through and I would take an average of all the total boxes that I came up with. So I would average my 10 numbers, and then I would write a nice little sentence to wrap it all up neatly, and I would say, it seems like it takes about 6 boxes of Wheaties to get a complete set of cards. Okay? So you need to have a conclusion statement. Does that make sense? All right. I'm going to do one more example today. And then again, tomorrow we can do more examples. I'm going to give you guys some more examples during class tomorrow. The problem is just that they're all a little bit different, and so you just have to think through what the simulation is going to be each time. And so they're all just, you have to just keep practicing. That's the only thing, you just keep practicing these.
Like the simulation itself.
Yeah. Yeah. All right, so here's the next one. I've got 10 minutes. I can totally finish this by the end of class.
Awesome.
57 students participated in a lottery for a particularly desirable dorm room, a triple with a fireplace and private bath.
Wow.
That seems, where are these people going to school? 20 of the participants were members of the same varsity team. When all 3 winners were members of the team, the other students cried foul. Could an all-team outcome reasonably be expected to happen if everyone had a fair shot at the room? All right, so this time we don't have all of those things listed out, so we're just going to write it in paragraph form, okay? Now, this time we're not based on percentages. We just have 57 students, okay? So we're going to have 57 numbers. Everyone clear on that? It doesn't have to be based off percentages. So we start with a component. One component is what? What is the building block of this? What is one number going to represent? One person. One component is one student. Right? Then you need to go through and assign your numbers. If you're using your calculator, it doesn't matter. If you're not using your calculator, it might matter more. I don't know. There's zeros in the lists. So that's why if you're using a table, you might want to start at 0, because there are zeros in the list. Okay, so how do you want to assign your numbers? 20 of them are varsity athletes, and the other 37 are not. So you want to do 0 to 56 or 1 to 57? Somebody tell me.
10 to 67. No, 10 to 67.
No. Okay.
No, that way there's not like one.
No. All right. 0 to 19 then can be our varsity athletes. You would write this in sentence form. I'm trying to save space. And 20 to 56 would be other people. I don't know what to call it. Other students.
So wait, why is it 0, 0?
If you're using a table, you have to look at double digits because it goes to a double digit number. So you have to look at 0, 0, 0, 1, 0, 2. In your calculator, doesn't matter. You just do 0.
What is the table to, like, what is the 2 digits?
Perfect. So let's say you had 17, 9, 0, 26. That's your table, right? You have to look at 2 digits at a time. So 17 would be a varsity athlete. 90 is not in your stuff, so you can actually skip over it. And then you go to 26. But that's, again, why you have to look at double digits because you have. Okay. All right. So everyone get with the assignment of numbers. Then we talk about what each trial is going to look like. So what is happening in this scenario? How many students are they picking for the dorm room? 3. So each trial we are going to do what? Each trial, and this time we're just picking 3 people. We're just trying to see if you can get 3 varsity athletes in the room, right? So we're not trying to pick people until we get 3 varsity athletes. We're just trying to see what happens with the 3 people assigned to the room. Are they all varsity athletes or not? Right? So each trial, we will generate 3 numbers to simulate the 3 students. Does that make sense? So again, they're all just a little bit different. You should think about the scenario so you make sure the model scenario correctly. All right? Then what's the response variable? What am I really worried about with the whole outcome of this? What am I trying to figure out? Right, we want to know how often that's going to happen, right? How often we get 3 varsity athletes. All right, so we're going to do this. Again, you should do 10 trials. I'm going to do probably 3 because I'm just going to be lazy at this point. I'm running out of time. Okay, 4. Bailey says 4. So we're doing 4. Now, my result is just going to be who's in the room. And then I'm really just worried about yes or no, there's 3 varsity athletes. Like I'm not trying to count anything this time, right? We're trying to see if there's 3 varsity athletes or not. Now, here are some good things to know. If you get the first student is not a varsity athlete, then obviously there's not 3 varsity athletes in the room, correct? So you can write no. But if you're using a random number table, you still have to look at 3 numbers. If you're using a random number generator, you still have to look at 3 numbers. Okay? You don't want to just do 1 number. That's not what you said you were going to do. Okay? So this time we are looking at numbers 0 to 56. All right, so 5. That was a varsity athlete, right? 45 is not. So obviously this is not going to have people. And we do 1 more, not a varsity athlete. Not a varsity athlete. But I still need to do 3 numbers. Not and not, right? Now, you can also set this up. I'll show it to you tomorrow. You can set this up to pick 3 numbers at a time for you. All right, so it'll give you 3 numbers at a time. All right, I don't really advise that. This is fine, 3 at a time, but if you try to do like 10 at a time, it scrolls across your screen, and once you hit enter again, you can't scroll back. So, just saying, maybe you don't do that all the time. And then 1 more trial for Bailey. Oh, this decimal point's gonna mess me up. Okay. No, yes, no. Okay, so according to my simulation, which only has 4 trials, so it's not sufficient, I would say 0% of the time, right, 3 varsity athletes in the room. This morning when I did during first period, out of my 4 trials, actually I did 5 trials this morning, I had 1 time, so that's 20% of the time. That's why you need to do more trials, but it's feasibly 20% of the time that's not going to happen. Okay? Right. Exactly. So the more trials, the better, because you're going to simulate an actual outcome, okay? So then we need to write a nice little conclusion statement, and so we would say, again, 0% of the time, 3 varsity athletes were in the room. They're probably with an issue with the lottery, or 5% of the time. So when you start looking at the assignments tomorrow, so I'm giving you examples tomorrow. We can do some more in class if we need to together. But I get them to you tomorrow. When you start looking at my answer is not going to be the exact same answer that you get. Your setup should be similar, if not the same. But your result is not going to be the same because everyone's calculators and things are different. Okay? So maybe I'll have 15% and someone else have 27%. It just kind of depends on what's happening with your calculator and your numbers. Okay? Questions, though, about how to set up a simulation?